Walaikum salam. Today we are going to discuss, please give a heading, isomerism. Or you can say structural isomerism. This is a unique phenomena of structural isomerism in the organic compounds. So in this type, please pay attention. What the organic compounds, they have. First you write definition and I'll explain. The compounds having same molecular formula but different structures are known as isomers or structural isomers. And this phenomena is known as structural isomerism. And this phenomena is known as structural. Now listen everyone. Please stop writing. If you look at alkanes, I told you the other day, if I write C4H10, this is an alkane with how many carbon atoms? 4. Please pay attention. Please pay attention. And if I ask you to draw the structure, the displayed formula, I told you how to draw it. What is the way to draw the displayed formula? You have to put all 4 carbon in one chain. And then you have to put in the functional group, as alkanes do not have any functional group. So let's fill up the hydrogens. Here are the hydrogens. And when you are filling the hydrogens, what you have to keep in mind, every carbon should have 4 covalent bonds. So this is the structure of C4H10. But recently, the other day, I told you that this is not the case. Always you can do this. There is another way of doing this. Instead of putting all 4 carbon in one chain, what we can do, we can put 1, 2, 3 carbon in a chain. And the 4th carbon, look at this. The 4th carbon, not on these 2. Please pay attention. Not on these 2 carbons. The terminal carbons cannot have the branch. The 4th carbon is, I'm going to put it on the branch, but not on the terminal carbons. Because if I put it on the terminal carbon, it will be like this. It's not a branch. It's just like the straight chain bending downward, right? So it's just like you hammered it down. So it's not a branch. Branch is only when you leave the terminal carbon alone and then put the 4th carbon here, the center carbon. And now fill up the hydrogens. 1, 2, 3. Okay. 1, 2, 3. Here. 1, 2, 3. Now this is again C4H10. Other day I told you, now these 2 compounds having different structures, they are the two different compounds. Their names are different. If I write them, this is called butane. You are not supposed to know how I'm going to write the name of the other compound, but I'm going to write it here. This is 2-methyl propane. This is not the part of the syllabus, that's why I'm not telling you. I'm just telling you that these are the two different compounds with two different names, with two different properties, set of properties, right? But they have one thing common. What is that thing common is? Molecular formula. These compounds are known as structural isomers, right? So
the molecular formula that means they have the same general formula. So how are they both two different compounds?
no, general formula is the formula which represents a whole group of compounds. Could be thousands of them. For example, the general formula of alkane is CnH2n plus 2. This is for all alkanes, even if they are not isomers. For example, methane and ethane are not isomers, but their general formula is the same. General formula is to represent a homologous series, the whole group, right? But when a compound with one molecular formula have two different structures with a different set of properties, they are known as isomers, right? And in alkanes, you see the isomerism is just like putting the straight chain carbons in the form of a branch. For example, let me give you one more example, C5H12. This is another alkane with the molecular formula C5H12. Look at this. The one structure says 1, 2, 3, 4, 5. How many carbon atoms? 5 in one chain. So it is like this. 1, 2, 3. H12, in which all 5 come in one chain here. Here is carbon number 1, 2, 3, 4, and then 5. How many carbon atoms? 4. And where is the fifth one? Yes, I have to put it in the form of a branch. Look, I'm going to put it here.
vertically draw करेंगे फिर उसके ऊपर हाइड्रोजन के एटम्स
You can draw it anyway. Just make sure that there are 4 carbon in the chain now. Look, 1, 2, 3, and then 4.
So generally one or two is just
Yeah. These two compounds have same molecular formula but the different structures. This compound is named as pentane, and this is named as what? 2-methyl butane. In this case, there is another possibility. Look, I'm going to put 3 carbon in the chain and 2 branches. This is also having same molecular formula, C5H12, if I fill in the hydrogens. Look.
सर हमें ये किस तरह पता चलेगा कि मिथाइल
Sorry.
हमें ये किस तरह पता चलेगा कि ये मिथाइल है
Sir, how is it methyl butane?
As I told you, the names which I'm writing here, we are not supposed to learn how I'm writing. I'm just writing it to tell you that these two have a different names. Okay, you
Sorry,
are
so
not
what
supposed
if
to know. Sorry, this compound has
what
a
if they
name.
give us a
No,
compound
no,
and ask us to name it?
no. This is not the part of the syllabus. 2,2-dimethyl propane. I'm just writing the name to let you know that look, these are the three different compounds with the three different names having one thing common. That is what? Molecular formula. And they are known as what? They are known as structural isomers. Okay? And this phenomena is known as, excuse me, I need your returns. Can you come here? Come here. These are known as structural isomers, right? Similarly, now come to the alkenes, right? Similarly, come to the alkenes. So I hope you understood in alkanes, when all five in one chain and you put them in the form of the branches with the same molecular formula, they'll be the different compounds, different structures, but having same molecular formula, they are known as isomers. Now let's see in alkenes what happens. Look at the alkenes. If this is an alkene, C4H8, if I draw it 1, 2, 3, 4, here, here, here. What is this? Yes. Now listen, everyone. Please, parents. Please, parents, stop writing. No. But I'm going to rejoin with the other device. Just give me 30 seconds. Let me tell you this. In alkenes, what happens? In alkenes, uh, if you have 4 carbon, you put them all in one chain. It's a 4 carbon alkene. Okay? So if you put them in one straight chain, now when you put the double bond, I told you the other day, when you are making an alkene, it doesn't make difference. You can put the double bond anywhere you want, right? But today I'm saying, yes, you can put the double bond anywhere. That will make an alkene. But if you put the carbon, the double bond between first and second carbon, there will be a different alkene from the one if you put the double bond between second and third carbon. This type is known as, again, they have a different structures. They have a different compounds. They are a different set of properties. But one thing that is common in them is what? Their molecular formula. So as long as their molecular formula is the same, but the structures are the different, what do you call them? They are known as structural isomers. They are known as structural isomers. Just I'm sharing my screen. Just give me 1 minute. Right? So again, what I'm saying that in alkenes, when the position of the double bond changes, it will be a different compound. It will have a different structure and it will have a different compound. I'm just sharing my screen. Just please hold on. Okay. Similarly, as we had in alkanes, when we put the carbons in the chain, that also made a different structure and different compound. That is also the structural isomers in case of alkene as well. For example, there are 4 carbon alkene. You take 1 carbon off from the chain and put it in the form of a branch. Will make another structure? Yes. That is another alkene? Yes. and that is also known as structural isomer, right? So if I sum up all what I'm saying, that in alkanes, you just have to take the carbon off from the chain and put it in the branch. So they'll have a different structure known as isomers. In case of alkenes, you can take the carbon off in the chain to put it on the branch.
एक्सक्यूज मी सर,
Yes,
आपकी स्क्रीन नहीं शेयर हो रही।
just give me 1 minute. I'm sharing it.
जी ठीक है।
Just 1 minute, please. Do you get it? So this is how we look at it. Okay, just give me 1 minute. So now, therefore, we have to learn a slight bit of this. Let me share it. Yeah, just hold on. I'm sharing my screen. Okay, fine. Okay, coming back. Sorry. This is how what I was telling you. If this is an alkene, C4H8, here it is. It's an alkene, C4H8. Now, what I'm telling you, because in alkenes, once you change the position of this double bond, for example, 1, 2, 3, 4, here are the 4 carbon. If I put the same number of carbon in the chain, what I told you, and put the position of double bond here instead of here. So now 1, 2, 3, 4. So my question is, as I just said, and asking you now, are these two different alkenes? Yes, these two are the different alkenes because their position of double bond has been changed. Over here, it is between carbon number 2 and 3, and over here, it is between carbon number 1 and 2. Okay, so what is the name of these two alkenes? Yes, one is butene and the other one is butene. How we name it? Now listen, everyone. We just have to number the carbons. Look, starting from the end where you see the double bond. Okay, so which end is the double bond for the? Here is the alkene. If somebody asks me, name this alkene, double bond, right side or the left side? Which side of the chain? The double bond is on the right hand side or on the left hand side? Right hand side. I'll start numbering from that side where the double bond is. And I number every carbon in the chain. Now there are how many carbon in the chain? And where is the double bond? Between carbon number 1 and carbon number 2. So I'll pick up the smaller number and I'm going to put that number before the ene. Ene is representing double bond. Na? So what I'm going to write here, I'm going to write here as but 1 ene. What is this? But 1 ene. What is on the side there? What about if I start the chains? So I have to see where the double bond is near. Which side is the double bond near? Which side is the double bond near? One, two, three, four. So now where is the double bond? Between carbon number 2 and smaller, what is that? So this compound is named as but 2-ene. Ene is the double bond, so I have to. And whenever in organic, whenever you put any number, you have to put a dash before that. Because in normal English language, you have to use the space bars, the spacing. Over here, there is no spacing. It's a one word, but 1-ene. Just like that, it is a one word, which is but 2-ene. Okay? So this is but 1-ene. And what is this? This is but 2-ene. Okay? Similarly, look at this. Now, these two are known as structural isomers. Third one, as we used to make for the alkanes. Third one is the same as we used to make for alkanes. Instead of writing the chain, I'm going to put 3 carbon in the chain now, 4th carbon as a branch. Can you do it, please? Put 3 carbons in the chain. In that case, no, look at that, please. Put 3 carbon in the chain. Yes. Let me see what's wrong with internet. There's some technical issue going on. Those who are on the Zoom, please bear with us. Look at this now, please. How many carbons in the chain? 3. And I have look at this. What about this? I have to put 3 carbons in the chain, double, and then 1 in the name. You are not supposed to know, but I'm going to write the name 1, 2, 3. There are 3 carbons in the chain. Now, I have to put the 4th carbon in the branch. This is again C4H8. The name again, you're not supposed to know how I'll give the name, but the name of this compound. So what I'm going to tell you that these are one structures, but one structure isomers.
सर आपकी आवाज कुछ लैग हो रही है।
They are also known as structural isomers. I hope you got it. In organic chemistry, one molecular formula, different structures, the compounds are no structural isomers. They are actually the different compounds physically existing with different set of common thing is their molecular formula. Therefore, they're known as structural isomers. One thing which you will learn today, other than branching, if you change the position of double bond, comes a new compound, a new alkene, which is different from the previous one, but as they have the same molecular formula, so we call them structural isomers, right? So one thing is butanene, the second one is butene, and third one is 2-methylpropene. All three are structural isomers, molecular for A. Okay? Okay, next. Here we go. Now, I'm going to sum up this, what we have learned up till now. What we have learned that in organic compounds, quickly going through it, is a carbon containing, and there are two types. One is hydrocarbons, and the other one, we leave them. Hydrocarbons are of two types. What are those two types? Saturated and unsaturated. Saturated containing carbon-carbon, single bond. Unsaturated containing carbon-carbon, double bond. Then I told you organic compound containing saturated, all of them saturated. And we learned this organic compound containing the unsaturated known key, right? Then we learned that the alkenes general formula. Those who are on the Zoom, can you see my screen?
Yes, sir.
Yes.
अभी उस पे वो अल्कीन्स तो लिखा हुआ नहीं आ रहा, अभी हाइड्रोकार्बन्स और ये सारा कुछ लिखा हुआ आ रहा है.
एल्केन्स
sir.
आ रहे हैं.
I think now it's coming. This is what I write. Carbon containing compounds are organic compounds. Then there are the hydrocarbons. Which one? Saturated and unsaturated. Alkene has a general formula CnH2n. Alkene has general formula. Both of them are making what? If I start with alkane, CH, right? I C5 is 10, right? Both of them are making what? Homologous series. It means, when does it mean? It means their compounds differ by what? One. So when I make a homologous series, what does it mean? Differ by C2H6, C3H8, C4H10. How much they differ? They differ by one carbon and two hydrogens. And when they make a homologous series, what set of properties they have? All the member compounds have same chemical properties. All the member compounds can be represented with one general formula, and their physical properties gradually increase. number of carbon atoms. Then we learned that the functional group for alkene is what? Carbon-carbon, double bond. Functional group is identification. Usko dekh ke we will see an alkene. As long as I see, as soon as I see this double bond, I can see it's what? It's an alkene. On the other hand, if there is no functional group as such for alkane, and one thing which we learned in the end is the phenomena of a unique phenomena of isomerism. That one organic compound with one molecular formula having different structures is a different compound, and they are known as structural isomers. In alkanes, butane has two structural isomers, pentane has three structural isomers. Similar, and how they are different in structures because their number of carbon in the chain were different. But on the other hand, in alkenes, even if the position of double bond changes, for example, in butanene and in butene, if the position of double bond changes, so these two are with the same, which is C4H8. Okay, this is how we look at organic compounds. We'll continue this. Now we are going out of the hydrocarbons and we'll discuss the other compounds in the next class. If you have any questions, please go ahead. Otherwise, we are going to stop it here today. Right? Thank you very much. There's a technical issue going on, so मैंने आज class थोड़ी short